So here's another free response question. This is from 2003 AB exam, Form B. It's problem number 2, which was a calculator question. And the setup tells us that we have a tank that has 125 gallons of heating oil at the beginning of a time frame. During the time interval from 0 to 12 hours, heating oil is pumped into the tank at this rate, that's measured in gallons per hour, and oil is also removed from the tank at this rate, also measured in gallons per hour. Part A wants us to figure out how many gallons of heating oil are pumped into the tank during the 12-hour time frame. So what we have to work with here is we have this function h of t, which represents the rate at which water is pumped into the tank. Now, given the nature of this function, you should realize that it's not a constant rate. You know, if this piece weren't here, if it was pumped in at a rate of 2 gallons per hour, this would be a very easy question to answer. We would just do 2 gallons per hour times 12 and we'd have our answer. But if we have a rate of change that's not constant, as most rates actually are, and we want to figure out how much change actually happens across a certain time frame, what we need to do is we need to integrate that rate of change across the appropriate limits of integration to get our answer. So we're going to take h of t, which is measured in gallons per hour, so the units of this are gallons per hour, times dt, and dt is measured in the same units as t, hours, so gallons per hour times hours gives us units of gallons on our result, and the number of gallons that this integral represents from t equals 0 to t equals 12 will be how much water has entered the tank over the course of this time frame. Now this is definitely a calculator problem, so I already have my calculator ready to go here. And I have h of t in as my y1 equation, and this is just the standard viewing window. And if you're interested in doing an integral from the graph screen, the one thing that I want to make sure you're aware of is if you go into the calculate menu and you grab this integrate feature, the 7th option, when you give it your lower limit of integration, which is 0, and then it asks you for your upper limit of integration, if you try to type in, oops, not 10, but 12, like it is over here, what ends up happening is it tells you error, something's invalid. Your calculator cannot do an integral from the graph screen unless the limits of integration are contained within your viewing window. So our viewing window, the standard viewing window, has a maximum x value of 10. And so what we would have to do is we just have to adjust our window settings a little bit. So let me get out of this. We'll go into the window settings. If I change this to 12, that should be okay. If I extend it a little bit beyond 12, that would definitely make sure that we're capable of evaluating the integral from the graph screen. So option 7 from out of the calculate menu, lower limit 0, upper limit is 12, and now it will do that integral. And as always on a calculator free response question, we want to carry 3 digits of accuracy. I could truncate it. I could write down 70.570. I'm going to do the normal rounding off of that value though. So I'm going to jot down 70.571 as my result. The AP exam would actually not give you credit for 70.5 or 70.6, and then that would be measured. It doesn't really ask for units. From time to time these questions are going to ask for units, and we already talked about the units of this result, so we'll go ahead and we'll tack them on at the end. Part B here says, is the level of heating oil in the tank rising or falling at time t equals 6? Give a reason for your answer. So you saw in my calculator when I was in this screen in part A, I do have my calculator ready to graph the rate at which water leaves the tank, or excuse me, it's not water, the rate at which heating oil leaves the tank too within this time frame. And if I go ahead and graph both of these, actually I want to get that shading out of there. So I'm just going to turn this graph off briefly, hit graph, and then regraph that. So I just didn't want that shaded region to be appearing any longer. We're done with that integral. I'm going to manipulate my window settings a little bit more as well here. So we don't need to concern ourselves with any negative values of x or values of t. So I'm going to start this at 0. And these rates of change are both positive. So I'm going to change that to 0. And I think I'm going to change this to 15 just so we can see up a little bit higher than we could before. So we look at this graph, and this is the graph that represents the rate at which oil enters the tank. And then this is the graph that represents the rate at which water leaves. Why do I keep saying water? The rate at which heating oil enters the tank. we want to know if the level of heating oil in the tank is rising or falling at t equals 6. Well, let's find where t is equal to 6 here. So if I go into the calculate menu and I take this value feature, if I type in the x value of 6, it'll take me to, and I'm on the graph of y1 right now, and remember y1 is h of t here. So it tells me that at 6, the y value on h of x, or h of t, is 5.39. So I know that h of 6 is about 5.39. Just by looking at this graph, you can see that at the x value of 6, or the t value of 6, the other function is going to have a larger value. So if heating oil is entering the tank at 5.39 gallons per hour at t equals 6, and heating oil is leaving the tank at a value slightly larger than that, what you're going to be able to say to answer part B here is that h of 6 is 5.39, which is going to be less than r of 6, the rate at which heating oil is leaving the tank. And what this implies is that the level of heating oil in the tank is falling at t equals 6. We'll wrap up part C and part D in a different video.